All right, today we're going to be doing the integration of rational functions by partial fractions, which is on page 115 in your packet. I'm just going to do a couple of the problems that are on that page and to show you how to do it. You might be wondering, what is this finger doing on the page? Well, we're going to use our fingers today because, like I said, I don't know if Mr. Lloyd has shown you these things, but we do need to use our fingers to cover up some of this. And I am missing, I am missing something on my, hang tight for a second. Let me change number 10. Put a little 3 on here. There we go. My x cubed didn't make it over. Okay, let's start with number 1. What we do when we have these, this is a rational function that we cannot take the integral of yet, the way it is. If we were to use the u as the denominator, x squared minus 3x plus 2, then our du would be 2x minus 3, which does not match up with the top, so we have a problem. And we're going to use this method that I'm going to show you when the degree on top, which is a 1 here, is smaller than the degree on the bottom. And I'll show you what to do if the degree is higher, which is the back of this page, page 116. All right, what we want to do first is we want to go ahead and factor the denominator. We don't care about the numerator right now. So we're going to leave the 11x minus 15 on top, and we factor the bottom. X and x, factors of 2 are 2 and 1. We want them to both be negative. Okay, now we split this up. We're going to split it into the partial fractions. One is going to have a denominator of x minus 2. One will have a denominator of x minus 1. Now, to figure out what's on top in the numerator, what we do is we take our finger and we first, I'm going to work with the x minus 2. If you take x minus 2, set it equal to 0, you get x equals 2. So what I'm going to do is I'm going to take my finger, hold on. I'm going to take my finger and I'm going to cover up. Well, first I have to make sure it's on top. So let's bring this to the front. Okay, so now I'm going to bring it over. I'm going to cover this up. And while that's covered with your finger, plug in the x equals 2. So I get 11 times 2 minus 15 over 2 minus 1. And that's going to give me, let's see, 22 minus 15 is 7 over 1. And I'm going to move my finger so I can get to this, and I'm going to put a 7 on top. Now we're going to do the same thing with the x minus 1. We set x minus 1 equal to 0, and obviously x equals 1 is the number we're going to put into our rational function over here after we get rid of the x minus 1. And we have 11 times 1 minus 15 over 1 minus 2, which gives me 11 minus 15 is negative 4 over 1 minus 2 is negative 1. So I'm going to put a positive 4 on top. And now this is simply taking the integral of basically 1 over x minus 2 and 1 over x minus 1, which is your natural log. The 7 gets to go out front. It just stays. And so we have the ln, absolute value of x minus 2 plus 4 ln, absolute value of x minus 1 plus c. And that's it. It has taken something very complicated and made it very simple. All right, let's take a look at number 10. Bring my finger down here so I can use it. All right, in number 10, what's complicated about number 10 is that the bottom is difficult to factor. If we look at the numbers 1, negative 8, do they have the same relationship as 19 and negative 12? No, they do not. I cannot multiply 19 by negative 8 and get negative 12, which means I cannot use grouping to do this. So we're going to go back to pre-calculus, because I imagine that's probably about the last time you saw, well, maybe you saw it a little bit in AB, how to factor a polynomial. What we want to do is get our possible real zeros, which are the factors of 12 over the factors of the leading coefficient, which is 1 in this case. So, and you just put plus and minus with all of them. So plus and minus, the factors of 12 are 1, 2, 3, 4, 6, and 12, all over plus and minus 1. So the nice thing is that these are all of our possible zeros that we're going to try in order to, oh, I just got rid of my 3. Hold on a second. Okay. Those are the numbers that we're going to try with synthetic division to try and find the zeros here. I'm going to cheat a little bit because I know what they are. And I'm going to use a 3. And it depends on your teacher how you set this up. It might be a little box around the 3. I've always used a large box around the polynomial. Put in your coefficients. And if there's anything missing, for instance, if I did not have an x squared term, I would put a 0 as the next number. So a 0 for any missing terms. But we have all of our terms here. We have an x cubed, an x squared, an x, and then our constant, negative 12. Bring down the 1, multiply it by 3, and put under the next term. Add, you get negative 5. Multiply by 3, and you get negative 15. Add straight down, you get 4. Multiply by 3, you get 12, and then 0 is your remainder. So at this point, I have a quadratic, x squared minus 5x plus 4. If you get a number that is not 0 right there, you have not yet found one of the zeros of the function. So you try a different number. So I might try a 2 or a 1, and I can try a positive or a negative number. I would never start with the largest number, by the way. Okay, so we have a quadratic that's going to factor into, it looks like, minus 4 minus 1. And now this gives us a factor of, because it's x equals 3, if you set that equal to 0, you would subtract the 3. So your other factor is x minus 3. All right, let's go ahead and factor the bottom, and we'll use our finger and figure out what our fractions are and integrate. So we've got negative, actually I don't want to do that. I just want to, no I do, excuse me. X squared plus 22x. Don't mind me when I talk to myself. Okay, and I've got x minus 4, x minus 1, and x minus 3 dx. All right, I think I'll leave a little bit of extra space this time. And I'm going to set these up with x minus 4, x minus 1, and, sorry about that, that was my finger on the smart board. Okay, and x minus 3 dx. All right, so, oh, we got to bring it to the front again. Not that it's a big deal, but I like it. Okay, at any rate, let's plug in a positive 4. If we plug in a positive 4, we get, let's do that over here, x equals positive 4, negative 3 times 16 plus 22 times 4 minus 31 over That's going to be 4 minus 1 is 3, times 4 minus 3 is 1. And then you type it all into the calculator, you should get negative 4.
Matthew, ISO, please come to the front. Matthew, ISO, please come to the front.
Okay, now we're going to use x equals positive 1. Move my finger over. And when we put this one in, it's going to be negative 3 times 1 plus 22 times 1, and then minus 31. Okay, and then on the bottom we have 1 minus 4 is negative 3, and 1 minus 3 is negative 2. Type that into the calculator, and you will get negative 2. All right, one more. X equals 3. Negative 3 times 3 squared is going to be 9. And then plus 22 times 3 minus 31 over, okay, let's move that finger over so I can see what's on the bottom. And 3 minus 4 is negative 1 times 3 minus 1 is 2. Type that into the calculator and you're going to get 3. So now my integral is going to be, remember to leave those numbers that are on top out front, and then ln absolute value of x minus 4 plus, oops, get rid of that plus, it's minus 2 ln absolute value of x minus 1, then plus 3 ln absolute value of x minus 3 plus c. And there you have it. That's for just the front side of this page, page 115. I'll send another lesson on the back when the exponent or degree of the function on top is higher than the degree of the function on the bottom.